Good evening all. Now we will discuss about Kirchhoff's laws. Okay, Kirchhoff's laws are classified into two types. First one is Kirchhoff's first law or Kirchhoff's current law. Second one will be Kirchhoff's second law or Kirchhoff's voltage law. Okay, now we will discuss about Kirchhoff's first law. Okay, let us consider five conductors. Okay, let us consider five conductors having five different currents. Okay, I1, I2 are the incoming currents, I3, I4, I5 are the outgoing currents. Okay, this is a junction. Okay, junction is nothing but interconnection of three or more elements. Okay, first you have a clear idea about node and junction. Okay, node is nothing but interconnection of two or more elements. Interconnection of two or more elements is nothing but node. Interconnection of three or more elements is nothing but junction. The major difference is at a particular junction current should be divided, but at a particular node current may not be divided. Okay, that is the difference between a node and a junction. Okay, while solving problem I will show this difference. Okay, now see here it is a junction, right? This junction is having five different currents. I1 and I2 are the incoming currents, right? I3, I4, I5 are the outgoing currents, right? Kirchhoff's first law states that at a particular junction the sum of incoming currents is equals to the sum of outgoing currents. Okay, see here at a particular junction sum of incoming currents is nothing but I1 plus I2 is equals to I3 plus I4 plus I5. Okay, that is the statement of KCL. Another statement will be the algebraic sum of all currents meeting at a junction is equals to 0. Okay, the algebraic sum of all currents meeting at a junction is equals to 0. See here, if the current direction is towards the node, assign with positive sign. If the current direction is away from the node, assign with negative sign. The assumption is your wish. If you are assuming towards the node is plus, then away from the node you have to assign minus. Okay, now see here I1 and I2 are the towards the node, right? I am assigning with plus sign, plus I1 plus I2 plus I3, I4, I5 are the outgoing currents, right? Minus I3 plus minus I4 plus minus I5 is equals to 0, right? From statement 2. What is the statement 2? The algebraic sum of all currents meeting at a junction is equals to 0. If the current direction is towards the node, assign with positive sign. If the current direction is away from the node, assign with negative sign. Right? Again you will get same value, right? I1 plus I2 is equals to here minus I3 minus I4 minus I5, right? If I take into RHS side, you will get I3 plus I4 plus I5. Okay. Next, that is about KCL. Next, KVL. Kirchhoff's voltage law or Kirchhoff's second law. The statement of KVL is, let us consider three resistors R1, R2, R3 are connected in series across a supply voltage of V volts. Okay, here minus plus V is the supply voltage. Okay, before going to discuss this topic, first you have to know the sign convention across active element and passive elements. Okay, suppose if the battery direction will be like this, here it is minus plus, right? Current will flow from higher potential to lower potential, right? That means this is the direction of current. Okay, that means this is the direction of current. If the battery polarities are plus and minus, right? Now this is the direction of current. Okay, now for this element, if we consider a passive element resistor R, okay, now see here, this is minus plus. Based upon this current direction, okay, across passive element we will get plus minus. Okay, based upon this current direction, this is the direction of current only. Okay, similarly here, plus minus right source, then across resistor, based upon this current direction, the polarities will be plus minus. That means if the current direction is clockwise, we need to give polarities clockwise plus minus. If the current direction is anti-clockwise, we need to give polarity across passive elements like resistor, inductor, capacitor. We need to give polarities in anti-clockwise plus minus. Now see here minus plus, right? Here current I is flowing in this direction, higher potential to lower potential. Okay, now here V1 is the voltage across the first resistor, V2 is the voltage across the second resistor, V3 is the voltage across the third resistor. Okay, now see here, based upon these terminals, current is flowing in clockwise direction, right? Across passive elements, polarities will be in clockwise plus minus, clockwise plus minus, clockwise plus minus. Okay, now see here, the statement of KVL is the algebraic sum of all voltages in a closed loop is equals to 0. This is one closed loop, right? In this closed loop 1, 2, 3, 4 voltages are present, right? That means the algebraic sum of all voltages in a closed loop is equals to 0. While considering voltages, polarities will be plays a very major role. Now see here minus plus, I am considering minus V. Next for plus minus, plus V1. Again for plus minus, plus V2. Again for plus minus, plus V3 is equals to 0. Then V is equals to V1 plus V2 plus V3. Okay, this is from KVL. Okay, this is one statement. What is the statement 1? The algebraic sum of all voltages in a closed loop is equals to 0. The another statement of KVL is, from this equation, the sum of voltage rises is equals to sum of voltage drop. Okay, voltage rise is nothing but across active element always voltage rise. Across active element always voltage rise. Here it is a voltage source is an active element, right? That is nothing but sum of voltage rises is nothing but only V. Sum of voltage drops is nothing but voltage drop across passive elements, right? That is V1 plus V2 plus V3. That is the another statement of KVL. Okay, that is about KVL. Now see here, in from KCL, I1 plus I2 is equals to I3 plus I4 plus I5, right? Conclusions. Sum of incoming currents is equals to sum of outgoing currents from KVL. Algebraic sum of voltages in a closed loop is equals to 0. Or the sum of voltage rises is equals to sum of voltage drops. Okay. Okay. Remaining we will see in next class. Thank you all.